Hello, everyone. Today we'll start the topic function. So, as I mentioned in the previous classes, the chapters sets, relation, and function are always studied in a group, right? So, we have defined sets, different collections that I have a set of natural numbers, I have set of whole numbers, I have set of real numbers. In relation, we formed pairs, we formed connections between them using an equation like y equal to x plus 1. So which are the pairs that you can relate from A to B? What are the pairs that you are allowed to form in the relation are given according to the condition that was mentioned. Now in function, we go to one more step. So first we had Cartesian product. So if I had Cartesian product A cross B, it says that you need to form every single pair that there is from A to B. So if I had set A 1, 2, 3, set B X, Y, then A cross B, the set that form every single pair where the X coordinate is from the first set and Y coordinate is from the second set. And you have to form every pair. So A cross B was 1X, 1Y, 2X, 2Y, 3X, 3Y, right? Then this was product. Then when we went to relation, that if R is from A to B, then in case of R, what happens is if I give you an equation, then form the pairs according to the equation. Otherwise, whatever pair I want to form, it's on me. The only thing again I need to consider is X coordinate should be from the first set A and the Y coordinate should be from the second set B. Now, whether I want to form a pair or not, and even if I want to, the only condition I need to consider is this first coordinate, second coordinate, first set, second set thing. How many pairs I want to form, whether I want to form or not, that's completely on me. But in product, I did not have that luxury. I have to form every pair. In relation, it's on me how many pairs I want to form. So if I wish to, I can take 1x, I can take 2y. It is a relation. If I want, I can take 1x, 1y. If I want to take a relation, I can take 1x, 2x, 3x. It is a relation, right? If I want to form a relation, I can take 1x, 2y, 3z. It is a relation. Each each one of them are subset of A cross B. What is a relation? Relation is a subset of A cross B. Each one of them have pairs that belong already in A cross because A cross B serves like a universal set. It is every pair and relation takes some of them, right? So all the four relations are subsets of A cross B. Agree? What does function says? For a relation to be function, see, in order for me to say that it is a function, it first has to be a relation. That means I need to have pairs. In those pairs, the x coordinate has to come from the first set, the y coordinate has to come from the second set. Agree. But every relation will not be a function. What is the criteria? There are two extra things. In Hindi, we in Hindi we say कोई छूटे ना किसी को दो मिले ना कोई छूटे ना none of them should be left. That means none of the elements of the first set, which is A, none of the elements of the first set am I allowed to be left unpaired. None of the elements from the first set are allowed to be unpaired. That means in my first set, for this example, I have 1, 2, and 3 in the first set. Every single element has to be paired up with someone or the other. I can't leave them unpaired. That's not allowed in function. So my first criterion function is each and every element of the first set has to be used, has to be paired. So like in the first example, can I say that this is a function? Can I say that this is a function? Example number 1, guys. Can I say that it is a function? Number 1 here. No. 1 is paired, yes. 2 is paired, yes. But 3 is not paired. That element of the first set is left unattended, is left unpaired. So no, it is a relation, but not the function. Why? Because 3 is not paired. Am I clear? Guys, am I clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What about the second example? Is this a relation? Yes. Is this a function? Is this a
No,
function? The
ma'am.
second example.
No, ma'am.
Why?
Only one is there.
2 is not paired or 3 is not paired. You give me a pinpoint. 2 is not paired. I'm fine. It's not a function. It's a relation, but not a function. What about example 3?
Yes, ma'am. It's a function.
Yes, I'm not bothered with the second set. My only botherness, my only worry is about the first set. All the elements of the first set has to be paired. I don't care about the second set. Like the y is not paired. I don't care. 1 is paired, yes. 2 is paired, yes. 3 is paired, yes. I don't care where. So yes, it is a function. Is that okay? Now, in addition to this condition that none of the elements of the first set can be left unpaired, there is one more condition. There is one more condition. The condition is, in Hindi, as I said, koi chhute na. The other condition is, kisi ko do mile na. Again, this condition is about the first set. Everything that we say in the definition of function is about the first set. None of the elements of the first set has to be left unpaired, and none of the element of the first set can go to two different places. One has to be paired. I don't care with whom, but only with one. Two has to be paired. Anyone, but only once. Three has to be paired, but only with one. Whom? I don't care. Like in example 3. Is 1 paired? Yes. Is 2 paired? Yes. Is 3 paired? Yes. So my first criteria is satisfied. All of them are paired. None of them is left unattended. My second criteria, they can only be paired with one element, whosoever. So 1 is paired with how many people? 1. 2 is paired with only 1. 3 is paired with only 1. I don't care who. They are paired with only one. So yes, according both my criteria, both my condition, the entire definition of function is satisfied. So yes, it is a function. Yes, it is a function. Online clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What about example 4? Is it a function?
Yes, ma'am.
Yes, 1 is
Yes,
paired with
ma'am.
only one element, 2 is paired with only one element, 3 is paired with only one element. None of them are left and none of them goes to two different places. So yes, it is a function. What about the fifth one?
No, ma'am.
No,
Why?
ma'am.
No.
Ma'am, because X and Y are
One
paired with.
goes to two different places. One is paired with two different persons. So it's not allowed. Yes, all of them are paired, but one goes to two different places. So that's not allowed. So no, it is not a function. So what does function say? That a relation, for a relation to be function, it has to satisfy two conditions. Each and every element of the first set has to be uniquely related with an element of the second set. I don't care with which element. Clear? They can share, like in example 3, X is shared between 1, 2, and 3, all of them. I'm okay. They can be different, like in example 4 also. But they can't go to two different places, like in example 5. But you can't leave any one of them, like example 1 and 2. Am I clear? Definition. Heading function. We are teaching, we are learning functions. A relation. For relation, we used to use a capital letter. For function, we use any small letter. A function, a relation f from A to B is a function if each and every element of the first set is uniquely paired with an element of second set. So a relation may or may not be function, but every function is 100% a relation. Because in function, what we are doing? We are forming pairs, right? So yes, it will be a relation, but it may not be a a relation is may or may not be a function, but a function will always be a relation. Oh, my fault. It has to be said. Otherwise, fourth was not even a relation. Otherwise, if in that case, fourth would not even have been a relation. Done? Write this example, please. Write this example. Okay, 1 second. If here there is no Z, then here it is neither a relation nor function, right? Because Z is outside. Done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, the initial construction, like I'll give you an equation, you have to form all the pairs, and you need to decide whether it is a function or not. The domain and range part. What was domain? All the x coordinates, range, all the y coordinates, codomain, or the second set. The basic definitions are the same. Yeah. Is this done? Question.
Yes, ma'am.
Uh, Note first. If number of elements in the set A is P, number of elements in set B is Q, then number of functions from A to B is second set to the power first set. Second set to the power first set. I'll explain you why. See, suppose in my first set I had A, B, C. So number of element is 3. My second set may have had 4 elements. So according to the formula that I gave, number of functions from A to B should be 4 to the power 3. Why? Let's see. Suppose in function, what do we want? I want to form the pairs of each and every element of my first set only once. So when I want to form the pair of A, how many options does A have? How many options does A have? Four. It can be
Or
A1 or A2 or A3 or A4. So A has four different options to be paired with. Yes. So A has how many options? Four options. What about B? B also has the same four option because it's not the case that if A has formed a pair with one, then B can't form a pair with one. I don't have a problem with that, right? So B again has all the four options. So four. Again, same C. C also has all the four options. Now I want to form pairs of each one of them. So in the chapter PNC, you learn that if I want to form every single pair, I'll multiply. If I want to form only one, I would have added. So I want all of them. So I'll multiply. So 4 multiplied 3 times, so 4 power 3. Yes. So always in number of functions, it is second set to the power first set. If I would have wanted number of relation, it would have been 2 to the power pq. If I wanted number of elements in the product, I would have written p into q. Is it understood? Everybody,
yes, ma'am.
please note this down. A1, B1 is allowed. A1, A2 is not allowed. That's why I've written only 4. If it could pair with more, I would have written more. So first pair 4, second pair 3, third pair this. In that way, I would have written. Done?
Yes, ma'am.
Let's say, let's do a question. Set A is -1, -2, 0, 2. F is from A to A. That means both the x coordinate as well as the y coordinate. What can they take the values? Only these four values, right? Function. Okay, now how will it be written? There are several ways to write it. Okay, now usually, please understand this one. The elements of the first set are denoted by x. That's because we write them in the x coordinate. The elements of B are second set. So y coordinate. And we write that x is related to y. So you are given a y equal to x plus 1, right? Y is dependent on x. Y is obtained from x. So here, again, the same notation, but we can also use y or we can use f of x. Like in polynomial you had, in polynomials we used to write t of x equal to x square plus 1. So if I put x equal to 1, I'll get in return 2. So what is 2? The value of 1. So here, y coordinate can also be written as f of x. It's the same meaning, just a different notation. So there are several ways in which I can give you the function. Say, first, f of x is equal to x square minus 2. This is an equation. So you put the value of x and in return you get the value of y or fx. Or I can write f is equal to x comma y such that y is equal to x square minus 2 as we wrote in relation. Or I could have written f is from x to x square minus 2. So if the x coordinate is x, then the y coordinate will be x square minus 2. So if I'm taking x coordinate to be 2, my y coordinate will be 2 square minus 2, 0. Understood? So I can write the function in any one of the way. It basically says that the equation that we need to follow is x square minus 2. Is it understood? Fx and y are same thing. It means the same value. So what do I want here? Question here. Number 1. Find f. So in this equation, we will put the values of x one by one. F of x is x square minus 2. The values of x that we are allowed are these four. So if I take x minus 1, f of minus 1 minus 1 square minus 2, that is minus 1. If I take x equal to minus 2, then every x will be replaced by minus 2, both in the left side as well as in the right side. F of minus 2. Minus 2 square minus 2, that is 2. X equals 0. F of 0. 0 square minus 2. Minus 2. F of x equal to 2. F of 2. 2 square minus 2. That is 2. Therefore, my function would be minus 1, the pairs minus 2, comma 2, 0, comma minus 2, and 2, comma 2. Does anyone have any doubt?
No.
Second, domain of x, domain of f. What was domain? Set of x coordinate, or I can say values of x that I used, or values of x, values of x. So what would be domain? What would be domain, guys?
Minus 1, minus 2, 0.
Minus 1, minus 2, 0, 2.
Range of f.
Range would
Value
be minus 1, 2, minus 2, 2.
minus 1, 2, minus 2. These three. I
Yes,
can't write 2 twice, no? Repetition is not allowed. Okay. Can you tell me, is it a function? Is it a function? Is it a function?
yes, ma'am.
Is it a function?
Yes,
Yes.
ma'am. Yes,
Yeah.
ma'am.
All the values of x were all the values of the first set were paired, and none of them are going to two different places. So yes, it is a function. All the four are paired, and all of them are going to only one number. So yes, they are paired. I don't care about the second one. Any doubts here?
No.
No,
No.
ma'am.
Is it okay? Question. Let f equal 1, comma 1, 2, comma 3, 0, minus 1, minus 1, minus 3, and so on. Be a function from z to z defined by f of x equal ax plus b. Find a and b. It's very similar to the question in the relation that we did. Find a linear relation if the pairs are there in this. So that is what we assume, let y equal to ax plus b. It's the same question. Yes, the question that determine the linear relation. So linear only ax plus b. So in order to find a and b, two variables, we need two equations. So f of x equal ax plus b. F of x means what? Y only. F of x is basically y. So take any two pairs, say 1, comma 1. Both instead of x and y, put x equal to. So 1 is equal to a plus b. F of x is y. Think it as this way. Y is equal to ax plus b. Instead of x, I'm putting 1. Instead of y also, I'm putting 1. When I have the pair 0, minus 1, instead of x, I will put 0. And instead of fx or y, I will put minus 1. So minus 1 equals 0 plus b. So b is equal to minus 1. A plus b was 1. A minus 1 is 1. So a will be 2. A will be 2. This is what we wanted. We wanted to find A and B, and we got A and B. Yes or no? It's a very
Yes.
same question like relation. So usually that comes because they won't even give you the equation. They'll tell you find a linear relation such that these are the pairs that I found. So you need to assume on your own that let y equal to ax plus b or let fx equal to ax plus b. Clear, everybody?
Yes, ma'am.
Okay, let's start exercise 9.
Yes, ma'am.
Exercise 9.1. Number 1. Which of the following relations or functions give reason? If it is a function, determine the range and domain. Number 1. Is number 1 a function?
Yes, ma'am.
Yes, it is a function. None of them are paired to two different elements here. So yes, it is a function. And what would be the domain? Domain is A, B, C, and D. And range is all the y coordinates B, C, D, and E. Number 2. Is it a function? Number 2. Is it a function?
No, ma'am.
No. Reason? 1 goes to 2 and 3 both. Third, is it a function? No. Because again, 3 goes to 2 different places. Number 4, is it a function? Yes, all of them are going to different places or only one. So domain 2, 4, 6, 8, 10, 14. Range 1, 2, 3, 4, 7. Any doubts?
Ma'am. No, ma'am.
Question number 2. X and Y are given. Again, which of the following are from X to Y? What about Roman 1?
Ma'am.
No.
No.
Why? Because 3 is left. 3 is not paired. Roman 2. Is it a function?
Yes,
Yes.
ma'am.
All the 4 elements minus 4, 1, 2, and 3 are paired and they are paired with only one element. So yes, it is a function. Roman 3.
No, ma'am.
No, because 1 is paired to 2 different places. Clear? In question number 3, we are given an equation f of x, x square plus 1, and x belongs to minus 1, 0, 1, and 3. I want to list down the elements of f. So if I take x minus 1, the answer would be
2.
2. If I take x0, answer would be
1.
If I take x1, answer would be
2.
If I take x3, answer would be
10.
10. Roman 2. The equation is twice x minus 1. X belongs to minus 2, 0, 3, 5. So function, if I take x minus 2,
Minus 5.
if I take x0,
Minus 1.
if I take x3,
5. 5.
if I take x5,
9.
so the range would be
Minus 5, minus 1, 5, 9.
range, all the y coordinates here, minus 5, minus 1, 5, and 9. Question number 4. There's an arrow diagram here. Minus 1 is with 1, 0 is it with 0. 1 is also with 1. 2 and minus 2 are both with 4. This is A and this is B. The function is from A to B. So f is equal to minus 1, 1, 1, 1, 0, 0, 2, 4, minus 2, 4. So is it a relation? Yes. Is it a function? Yes,
Yes, ma'am.
it is a function. All the elements are paired and are paired with only one. What do we need? Also find the rule. That means an equation. So can we find an equation between them? Can we find an equation between them? Y is equal to square of x.
Yes, ma'am.
Hmm? We could have also written as f of x equal x square, any which way, where x belongs to. Question number 5. P is paired with 3, Q is paired with 7, R is paired with 7, S is paired with 1. Write the relationship represented here. That means we can only write the pairs here. P3, Q7, R7, and S1. State the domain. Domain will be PQRS. What would be the range?
137.
7. What about codomain?
135 and 7.
Entire B 1357. The entire second set is the codomain. Is it a function? Is it a function? Yes, it is a
Yes,
function. None of the elements are left from the first set and none of them are paired with 2. Any doubts?
no.
Question number 6. It's written x comma 1 by x. We usually write what? X comma y. So instead of y, what have they given us? Y is 1 upon x, where x is in A and A is -2, -1, 1 and 2. Yes? So now what would be f? If I take x -2, it would be reciprocal -1 by 2. If I take x -1, it will be reciprocal. If I take x1, again reciprocal. If I take x2, it will be reciprocal. Domain -2, -1, 1 and 2. Range -half, -1, 1 and +half. All the y coordinates. Any problem, guys?
No, ma'am.
No.
Question number 7. F of x is given to be ax plus b, right? So now it's given f of -1 is -5. So see, instead of x, they have written -5 and the answer is given to be -5, which means here x is -1, the bracket is x, and after equal to which I have written is y. So x is -1 and the value of the function is -5. So if I put here, I'll get -5 equal -a plus b. Is it understood? Whatever is written in the bracket, that is f of x, na? So I've now written f of -1. So instead of x, we have put -1 in the entire equation. And the answer that I get for that is -5. We have done is what? X equal to -1. So f of -1 equal a into -1 plus b. And instead of f of -1, we have written 5. Now f of 3 is 3. Instead of x, I am putting 3 and the answer is also 3. Subtracting them, -8 equal -4a. So a is 2. -5 equal -2 plus b. So b is -3. That is what they asked us to find, a and b. A is 2 and b is -3. Any doubts?
No.
Question number 8. So f is equal to x comma 3x minus 5. X is belonging to R. So basically y is 3x minus 5 or fx is 3x minus 5. Yes or no? X comma y is what we write, right? And instead of y, they have written 3x minus 5. That means the value of y is 3x minus 5. Now a comma 4 belongs to f. So that means a and 4 has to satisfy the equation. Instead of x, we can write a, and instead of y, we can write 4. Yes or no? So 4 is equal to 3a minus 5. 9 equal 3a. So a is equal to 3. Is it okay? Then we have 1 comma b belongs to f. b equal 3 into 1 minus 5. b equal minus 2. So a is 3 and b is minus 2. Any doubts? Any problem?
No, ma'am.
All of you?
No.
So this is the part of function which is similar to almost very same to our relation part. But the main part of function is finding domain and range. When I don't tell you that set A is 1, 2, 3, 4, or you can form these pairs. What we will do is I'll only give you equation. Fx is x square. That's it. I haven't told you from where to where, f is from A to B, natural to whole. I won't tell you anything. You need to tell me what is going to be the domain and range. And that is the most important part in function, which will come in the exam, no matter where you're writing. Yes, we'll continue in our next session. Thank you.